Good morning, good afternoon, good evening, everyone. Welcome to the next session in our customer webinar series, How Attackers Move Laterally. I'm Shree Sheth, and I'll be your moderator for today's event. This series was created to highlight key resources, trainings, and best practices when it comes to getting the most out of the Vectra platform. Today's webinar will be led by Jonathan Barrett, Director of Consulting Analysts here at Vectra. Jonathan is an excellent resource, and today he'll be focusing on two incredibly important but complex and often misunderstood protocols when it comes to networks. I'll let him share more about that in a couple minutes. Let's cover some housekeeping items before we begin. If you take a look, there we go. Okay, perfect. Let's take a look at this. The recording of the session will be shared with you after the webinar. If you have any questions during the session, you can type them into the Q&A chat box at the bottom of your console, and we'll address as many as time permits. We've also listed a handful of resources we think you'll find helpful, as well as a quick link to our self-service ransomware demo. And with that, I'll let Jonathan take it away.
Thank you, Shree. Happy to be here with everyone today. Before we get started, just kind of a quick agenda. So first of all, I just kind of want to talk about what this presentation is and is not, followed by we'll get into a Kerberos and RPC primer, covering ways that this is used normally, but also from a attacker perspective. This is meant to kind of get into the detections that we have and help you figure out how to investigate. And a big part of that, we believe, is understanding these protocols to the extent that you're able to use them and pivot around with the data that you have. And then followed by that, we'll actually get into the detections and some general investigation tips there. Keep in mind that when we're talking about Kerberos and RPC, there's all different types of operations that could be done in different use cases. So we're not going to be able to get into like a flowchart for every single one, but we'll provide some high-level tips and recommendations on where to pivot and that sort of thing. So first of all, what this presentation is, it's an introduction to commonly and as we point out, sometimes not well understood protocols. We will be providing examples of how these protocols are used, and we'll show how they're detected within Detect. And as I mentioned at the end of the agenda, provide some suggestions for investigations. What this presentation is not is a deep dive into Kerberos and RPC. The idea is try to provide you enough information that you can do most investigations, sort of the Pareto principle, 80-20 rule, that sort of thing. So we're not going to get into every single opcode. Honestly, that would probably be a very dry webinar. Try to make this a little bit more actionable for you. And also just, to highlight, this is not a declaration that you should be blocking these protocols just because they're used by attackers. I'm sure a lot of you are sort of rolling your eyes or, hopefully chuckling at that notion, but, I think we've all seen sort of a request that come in like, hey, please block port 443 or 80 because I've read that most malware operates on those ports, right? So just putting that out there for anyone who may have that question. So getting into it, I want to start with a story. So I love amusement parks. So imagine my excitement when I got a chance to go to Kerberos Park. I had long heard of all of its selection of rides and food vendors. And now imagine my disappointment when I get to the front gate and I'm turned away. In my excitement, I forgot that I actually had to pay to get into the park. So from there, I realized I had to go buy a ticket. So I went to the ticketing station. I bought the ticket with my credit card. And this ticket allowed me to access the park and its rides and everything inside. I could play games of chance, get on the Ferris wheel if I so wish, and eat until I was full and or sick. But being the hot summer day that it was at the time, I wanted to head to the water slide first. So I take my park ticket, I go to the water park area, and I present my ticket to get a pass for the area. Alas, I was denied. I apparently did not have the right access to be able to get to the water park area. So much to my chagrin, I had to go find an alternative. And thinking of what might be second best, I decided that, feeling the breeze from a roller coaster is probably, just close enough to what I wanted on such a hot day. So I take my park pass and, I take it to the ticketing machine for the roller coaster, and I present my park ticket. Luckily, the roller coaster was part of my basic pass, and in return, I was given a ticket for the roller coaster. I then take that ticket and I present it to the attendant at the roller coaster. They took the ticket, and with that, they allowed me onto the roller coaster where I could enjoy the breeze through my hair. So I appreciate you all following along with me in that thinly veiled metaphor for Kerberos authentication. Kerberos can definitely get very complicated. I didn't even really get into things like cross-domain authentication, which, in this metaphor, I guess would be sort of a multi-park shared pass. But, by simplifying it and sort of explaining it thusly, I hope it sort of makes a little bit more sense as I go through the actual details. So actual Kerberos authentication. The way that this works is that the Kerberos user or park visitor, in the story I just told, makes a request to a key distribution center, or KDC. This is most often a component of AD. It doesn't necessarily have to be. But this authentication request, or a ASREC request, contains the account name, so the user, right, that's trying to authenticate. The KDC then sends back two messages. The ticket granting ticket, or TGT, which contains information such as username, the ticket granting server, or TGS name, timestamp, lifetime of the TGT, which would be effectively, how long I could stay in the park without having to get another pass, right? And the TGS session key. This TGT is encrypted by the KDC, and it can't be decrypted by the client. The second message contains a TGS name, timestamp, and the lifetime of the TGS session key. This second message is encrypted with the client secret, which is decrypted by prompting the user for the password. Right? This is me purchasing my park pass. Once this is done, the client sends back two messages in response. Once the encrypted session key contains the username and the timestamp. The second, a plain text message, contains the service name or desired ride of a requested service. It also includes a timestamp and the encrypted TGT. The KDC then checks that the service exists, and if it does, it decrypts the TGT and sends back two messages. One is the encrypted service ticket, which is encrypted, it's encrypted with the service secret key, and it can't be decrypted by the client. This contains information such as including the service key. The second message, sorry, lost my list for a moment. The second message is encrypted with the TGS session key, and the client will then have that cached, or if it has it cached, it can decrypt the second message and access the service session key. It's been validated that I can use the service or ride the ride that I want. The client or the user then starts communication with the required network resource. This client sends the name, the timestamp, and a single message, which is encrypted by that service session key. And then the service can decrypt that service ticket to obtain that service session key. It compares that information to the messages sent by the client and the information in the ticket. And once it's established that the information is correct, a session can then be established. Finally, this message is sent back to the client confirming the service name and timestamp, And once all that's been confirmed and authenticated, the user can then access the roller coaster. This can seem very, very complicated. There's a lot of back and forth. What this looks like from a metadata perspective, because all this is in the PCAP, this isn't in the network traffic. We can convert this to metadata. So if you have Recon stream, you're able to actually see this. Now, this is an example of that AS request. Things that you'll see here, so about, say, a third of the way down on the left is the client. So that is the user, right? Error code and error message, that's fairly self-explanatory. If there's an error there, we'll go over a couple of those, but we'll do that a little later. Originating port, response port, it's Kerberos, so predominantly it's always going to be over port 88. The originating host name, which is taken from the detect system through our host identification. Response name, this would be the domain controller, most likely again taken of host ID. The request type, as I already talked about in here, is an AS. You may also see this as TGS. And the service, which is the Kerberos SPN, or service principal name being requested within this particular request. So as I said, this all sort of seems complicated. How do we break this down? What I'd like to do is borrow from the model that we see within Privilege Anomaly, because really what this provides you is most of the information that you need to follow up on, right? So, at the top, you have the account. Again, the user that performed the action. Bottom left, you have the host. This is the host that the user account is operating from. And then third and bottom right, you have the service principal name, or the SPN. So this can kind of be broken down into two pieces, the service and the resource, which would be like the host and the realm that the host is in. And you'll see this kind of broken out as, the service / resource when you're looking at the traffic or looking at the metadata or the detection. As I mentioned before, when troubleshooting error or troubleshooting problems, the error codes can be useful, and we'll cover a few common ones. But I would say they're relatively self-explanatory, which is probably the only place I'll say this about Kerberos. But those are fairly well documented overall. So what are some of the common services, common SPNs? These are things that you'll see as you're looking through these detections. First off, you have host. This is actually a catch-all for several services, but it roughly equates to give me access to this host. And I'll explain why that's sort of important later. CIFS is accessing the file share of the system, right? Term serve, you may see this with an E or without. This is specifically Microsoft RDP or their terminal services. And then other ones are typically around protocol specific. So I call out HTTP in particular for web services, but you'll also see things like DNS, FTP, VNC, RPC, others. Sometimes these are sort of wrapped up under a host as well. It really kind of depends on your configuration. If you're looking for a good list here, adsecurity.org actually has a really good breakdown of a lot of the common SPNs and what they are used for. So talking about errors. So I just called out a few of the ones that are sort of commonly seen or you'll likely run into. So first of all, the KDC error C principal unknown and the S principal unknown. So these are both for the client C, service S, but basically in this, the DC is unaware of the items that are being requested or doing the requesting. So C principal unknown is, the user doesn't exist. And then S principal unknown is, the DC doesn't have the server name in its AD. KDC error pre-auth required and failed. These are actually fairly common. You'll see these a lot. Effectively what it means is that there's a pre-auth security feature that's been turned on. It's meant to prevent password guessing attacks. But if you just see these, like, don't necessarily be concerned about the fact that they're there trying to figure out what that specifically means. And then down the bottom, error client revoked and key expired. These are sort of two different ends of the spectrum for basically denying the user. So client revoked is the credentials themselves have been revoked. The account is disabled, maybe it's expired, maybe they've been locked out, that sort of thing. And with key expired, that's basically just saying the password has expired. The user needs to create a new password. But of course, the question is like, all right, well, what are some of the common attacks related to this? So I kind of walked through, Kerberos authentication, where it all comes, but how is this actually used by attackers? So I listed out a few common attacks here with Kerberosing, right? So basically, this is when an actor compromises a domain account. That account doesn't need to be privileged or administered or anything like that. It just needs to be joined to the domain. So, once the malicious actor is authenticated as the user, they receive that ticket granting ticket, that TGT that I was talking about earlier, from the KDC, and they then use that to request a particular service. So the actor may want to access a file server, let's say. They'll request that. The domain controller will retrieve the permissions from Active Directory and create that TGS ticket, and they will encrypt that with the service's password. So as a result, and we were talking about this earlier, where which pieces of the authentication were encrypted by what. As a result, only the service and the domain controller are actually capable of decrypting that ticket, since they're the only ones that actually know the secret. The domain controller provides a user with a service ticket, which they will then actually be able to take. The attacker will be able to take that out of system memory and crack it offline. So they'll be able to find that service password. This will typically be done using password cracking tools. Tools such as Impacket, PowerSplit, Empire all have automated processes to do a lot of this. That can then basically take the output and provide something like Hashcat to crack. I'm not going to get too much into those specific tools. If there are questions about that, happy to kind of answer them after, but not going to get into them during this presentation. So once they have that, they have that service account password, and they're able to use that as they wish. Another style of attack, delegation attacks. This is basically delegation is what allows service accounts to impersonate other users. This is, if you're logged into a web application, for example, that web app may impersonate you to pull specific data from a database to be able to show you what you need. Now, this is normal activity. This is expected. The problem lies in when that delegation isn't constrained properly, and attackers are able to use that lack of constraints to impersonate other users. Next up, gold and silver ticket attacks. Up there with Kerberos is probably the most popular, what people are most aware of, if they're aware of, if they're knowledgeable on Kerberos attacks. So with a golden ticket attack, basically what has happened is the adversary has gained control of the KDC service account, and they're able to write their own TGTs. This is in part why, when an actor gets on domain controller, and actually why they want to get on domain controller, why that's so damaging. They're able to write the tickets that they want and basically have full reign of the environment. And that's on top of the fact that they also, in theory, have all the passwords for all the users, in the network. And then at the end there is the replay attacks. So this is just like it sounds. Basically, what happens is, a message gets copied and then replayed to the service. So, what user, let's say Alice, makes a request. She's looking for a access to a particular file server, right, and request that service. The malicious actor can copy that service ticket, and then sometime later send that back to the file server, right? And then assuming that that server doesn't actually check some of the timestamps in there, which is part of the configuration, they're allowed to replay that ticket and gain access. And the malicious actor is then at that point able to masquerade as Alice. So, as you can see, there's multiple ways that malicious actor can actually gain access to what they need and utilize Kerberos during the course of their attack. But before I get into how we detect that, I want to talk about RPC and kind of walk you through that as well, because there's interplay here, right? So RPC remote procedure calls. I am going to, of course, do this by way of story, easiest to understand. And that story is simply, I turned on a TV with a remote. RPC is a little easier to explain via analogy. TVs have controls, or most TVs are going to have controls directly on them, right? You're able to access different settings, that sort of thing. And then the remote control allows you to do that from across the room remotely. And just like there's the joke about the complexity of AV systems and having either a single universal control or multiple remote controls for every single piece, RPC is also seen as very complex as well. So I think this is a fairly apt analogy. So what do we mean by RPC? So RPC is a major part of modern just networks, and technically, it want to be pedantic a little bit about it. RPC just means remote procedure call, and it could reference calls between applications or for specific programming languages. APIs are remote procedure calls, right? But what we're really talking about here specifically is DC RPC and MS RPC. Now, these are generally used interchangeably, and you'll hear that today as well. But the point is that these are part of most networks, and it provides this sort of general flexibility to users and systems to be able to communicate across, without having to have direct access. And this flexibility and this complexity is sort of what leads us up to sometimes having a bad rep, but as you can see, is absolutely necessary. But what is happening here? So let's take it back down to the actual endpoint. So if you think of typical software, it uses procedures or functions to carry out their actions on a given system. These are contained within dynamic link libraries, DLLs, right? These need to be loaded for the function to actually work. if you've heard the term DLL hijacking, but aren't actually sure what it is, right? This is what we're talking about, where these link libraries are, either replaced or basically utilizing the way that systems find DLLs, putting your own malicious DLL for software to run. And DC RPC, it enables this capability like on a local machine, but to do it remotely over the network. So you load interfaces, just like you do DLLs, and you call our functions with arguments, and you get a specific event at the end of it. So, RPC, in terms of authentication, it basically has a whole bunch of authentication methods. So, this can be done over SMB. This is done through NTLM, Kerberos, really whatever is open and exposed. The payload itself, as you can see here, this is an example of MSR RPC. This is actually taken from PCAP. The headers are visible, but the payload itself is what is encrypted here. Otherwise, this can be encapsulated, within SMB. If this happens as you're doing your investigations, you're not necessarily going to see specific authentication for the RPC. This is done as part of the general SMB. And then more commonly now, with Windows 10, you're seeing XML RPC. So basically, the request authentication is coming over an XML document. And what does this look like when you're actually breaking this down, right? So for RPC, the things that we're looking at here is, there's a UUID, so this is the endpoint. This is specifying like what is the library being accessed, right? What is the interface? This is, in a ID string that is unique to it, not human readable whatsoever. And then on top of that, you have an operation number, which is calling a specific function, which is referenced by an operation code. Again, unless you memorize these, not necessarily human readable. Things that you'll see here as well is a number of these calls are actually appended with either an A or a W. If you're looking at the traffic, and you'll see this in the UI as well. Really what that just means, A stands for ANSI, W means Unicode. Most everything now, you're going to see that W, but you, depending on what you have in your network, you may see that A appended. For our purposes, when we're talking about the operations that are happening and how we're investigating, it's inconsequential. That is useful in terms of understanding what the underlying machine is, but not necessarily what the operation that's being done. In the RPC calls, you'll see multiple pieces, and just to kind of highlight, what you're going to see. You'll see a bind request. This is, connecting to that actual interface. You have the authentication. That's the auth3. Again, this could happen through NTLM, Kerberos, etc. Any changes to the interface or adding an interface, you'll see this alter context. And then the request is the actual RPC call. As I already kind of pointed out in the previous slide, right, those identifiers, you have that unique identifier that is set during the bind. That's the context ID. You have the ID for the RPC sessions, and then you have the operation number. So that's the actual function call being made. So taking that from, PCAP into metadata, what is it that we're showing here? So in the DC RPC metadata stream, you'll have specific details for this protocol. Talking about a third of the way down on the left, you have a domain. This is, in this particular instance, the host, right? So it's coming from archer.local here. Endpoint, that is the interface or that library that we're talking about, right? Obviously, originating host IP, response host IP, along with the ports there, useful in terms of understanding, who's doing what to whom, but not necessarily specific to the RPC call being made. The operation, so that is that specific function call that's being requested. And then just like we had in Kerberos, right, we have the originating host name, response host name, which is all taken from detect in our own host identification. So again, okay, this is getting complicated. How do we break this down into sort of its core components? So borrowing a little bit from the design paradigm of the PAA, this is what we're looking at with RPC calls. All right, so at the top there, you have the account. This is the user account that's actually performing the action of making the request. Source host, right, where that account is operating from. The specific RPC call, which we can sort of break down in our investigation into endpoint and the actual operation. And then obviously the destination host, right? Where is this call actually being made, right? And from here, we have like sort of all the key components that we need to be able to pivot and investigate a given detection that comes in. Some common endpoints, and by no means this is an exhaustive list, just like the Kerberos SPNS was not an exhaustive list, but just kind of highlighting a lot of the information that's available out there through this protocol. LSA RPC, so that's local security authority, so being able to enumerate user privileges, trust relationships, SIDs, so being able to provide like, here's a list of usernames, giving back the IDs, security policies, that sort of thing. SAMR, so the security account manager, being able to enumerate domain users, domain groups, things of that nature. Service control manager, this is the creating, starting, stopping of services. So, basically, an executable is placed on a machine and kicking off the service to run that. AT scheduler service, being able to create and control scheduled tasks. So, this was, very popular, years ago, right, where attacker would get on the system, or a red team would get on the system, lay down its implant, and then kick off or create a scheduled task to run it. And maybe they would run it automatically so they get their full C2 back, or possibly let it sit for a while, say a couple of weeks, to provide some distance between like the initial exploitation and the actual sort of compromise and the actions that are being taken. And then DRS UAPI, so directory replication services. Most predominantly, you're seeing this with domain controllers, but this is data replication, and we'll talk about where this is important in a little bit. Now, the key thing to remember here, like I just laid out, several very common endpoints, and if you think from an attacker perspective, that's a lot of really good information. The problem is like 99% of the traffic and 9% of the usage of requests to pull that information or run those functions is normal. So you have administrators doing things remotely. They're not going to be able to access everything locally. Just general authentication, you'll see this. AD management, domain replication between DCs, endpoint management, patching as an example, your EDRs as they're communicating, you may see this sort of stuff, right? And this is not optional in Windows environments, Microsoft environments, right? So if you're looking at the metadata, if you're looking at the traffic, you're going to see a lot of this, and you have to, where detect comes in is helping to find the things that are actually suspicious of all that traffic, and we'll talk about that in a little bit. So, from the attack perspective, as I was saying, like, what's the information that we want? Like, all right, I want to know network sessions. I want to know the users. I want to know what do I have access to. DC sync, fairly popular. That's fake DC synchronization, using a normal process that you would see between domain controllers, and using that to pull all the data to, as the attacker and use it maliciously. For remote execution, WMI, service creation, things like PSExec, things that are common system admin tools, right? Scheduling tasks, things like that. Again, all stuff that you would, as an admin or as a regular user, or anything that you would want to do, but being turned around on us. And I'm not going to get too deep into these, but as an example of where this gets used, Bloodhound Sharphound is probably one of the more popular and well-known tools there. But this is using graph theory to basically map, how do I get from where I am to where I want to be, right? So it uses these function calls to enumerate AD and pull up systems, users, where those users are logged in, right? And then be able to sort of find that shortest path to the target. PSExec, again, this is part of sysinternals. It's used for administrators, but for those living off the land, or just this is usually readily available. We've also seen this copied when not readily available by attackers. So this basically allows for executing more commands and being able to read write to systems. So I know I just threw a lot at some of y'all, and the question that is going to come out of all this, right, is, well, okay, but how do we detect this, and how do we investigate this stuff? So I've laid out sort of the basics to help identify like the key pieces, and now let's kind of work through what this would look like if you're to start doing investigations. So with Kerberos, it's about detecting the usage of the access, right? So, as I showed, some attacks against Kerberos happen offline, like they're doing that password cracking, right? But if they're going to be forging tickets, if they're going to be cracking passwords, that sort of thing, they're doing it for a purpose. They're trying to get to somewhere. They're trying to gain access to something, right? So where we've focused as Vectra is on identifying this access and these attempted access. And the way that this is done is, through what we call privilege anomaly privilege anomaly analytics. The detection will say privilege anomaly and then a subcategory. And I'm just going to do a very high-level thing here. We actually do have videos that go far more in depth, actually by data science, and I fully recommend you go check those out. This is actually really cool stuff. But the idea being is, we're monitoring the usage of the Kerberos traffic. You can see who is accessing what. So things like printers are going to be very common, services that get requested. And as such, they're going to have what we call a low observed privilege, right? Meanwhile, the users that only access those types of services are going to have a very low observed privilege. As we start getting into the less used, so if a user begins accessing a few services that few other users access, their reserve privilege goes up. That starts hitting medium. And likewise, when you have users that access a lot of services that are rarely used by other users, that becomes high privilege, right? So the difference being here is if both of us are admins, we both have high granted privilege. However, if you're the industrious one that's always doing work, and I'm the lazy one that isn't using it, I'm going to have a lower observed privilege. So what that inherently means is that the usage of my account is more suspicious when we do access these type of services. And we do this, for accounts, for services, and for hosts. And what we end up providing is this triad, right? So the account, the host, and the service that I showed earlier, and we can identify which edges are suspicious based upon normal usage. So based upon whatever abnormality there is, we will flag that as a different sort of subcategory of privilege anomaly. In this particular instance, this user normally uses this service. However, there's not a relationship, or there has not been an observed relationship between the user and the host and the service. So we've triggered this as privilege anomaly unusual host. To make this a bit, more tangible, let's use this example, right? So from here, account is used to access a service from the host, which the account is not usually on, and there's not the relationship between the host and the service. So here we have, Ian IT's priv account access remote desktop service for an IT-only system. And they're doing it from host, Fred Finance and MacBook Pro, right? Where what we observed is only finance accounts operating from. So what this could be is a signal of a stolen credential that is now being used on a different host as an attacker moves laterally across the network, depending on what the actual goal of the actor is. Like maybe it is financially motivated, and that's why they're moving to finance, right? That is something that they could be trying to do. And you would see this in the system as a detection, right? Where we would lay out, the account, the host, and the service, just like I talked about. And we show what is normal if there's learned normal activity. Now, to go back to what a few slides where I was talking about, the actual service and how we break that down, right? We have that term service request to IT dash only, right? So those are the two key components, and I'll explain why that's important just in the next slide, right? So what do we know? Like we know that the priv account for I and IT wants to RDP to that IT only. We know that the account is being operated from the finance machine. So how do we dig into this? So there's, first of all, we want to verify the RDP traffic. This is available, recall stream. We'd have a PCAP sample as well, but for simplicity, right, that metadata makes it easier to parse through. And when we start looking at that, what we want to pivot to is, well, what other services are being requested? We have access to the Kerberos metadata stream and searching specifically for the priv account from Ian, specifically from the Fred Finance machine. We can see what else is being requested. And from there, we can sort of glean as to what the general goal of the activity is, whether it's malicious or benign, right? And what we'd want to do in this case is, confirm additional suspicious behaviors, not just on that Fred Finance, but because we know that they're RDPing and they're accessing the system, we'd want to pivot over to that IT-only system as well, right? We'd want to say, like, okay, you've accessed the system. What are you doing on it? Do we see additional network behaviors that may sort of provide this campaign, if you will, the storyline as to what is going on? And then on top of that, using your other security tools to help confirm, if we have this activity, we see this traffic, right? Well, okay, are there other alerts coming from other tools that we have? Do those provide additional pieces of information as to tell us what's going on, right? So this is one example. Another example of PAA is unusual trio, right? Where we're saying the relationship between all three pieces is abnormal, right? So in this case, we're saying Dave in data science is accessing Fred in finance's MacBook Pro, and he's trying to mount drive IT only. He wants access to that file share, right? Those are the key components, right? And this is what it would look like in the actual system. Again, account, host, service. We have CIFS, IT only, right? And what is the actual normal activity? Well, you see Ian, IT Priv, typically accessing, from his MacBook, being granted access to the service, but we don't have any, we don't see anything else related to that. That's useful contextual information. So again, what do we know? Dave, data science, wants access to the file system to IT only. The account operated from Fred to finance. So what do we do? Right, so because we understand the service, right? All right, well, what traffic do we see, via SMB, what we call streams, that sort of thing. What other suspicious behaviors are we seeing, either on the system itself or, on the target system? And then again, using our additional security tools to provide additional context. So using all of this to better understand, what is actually going on. And this is where understanding these SPN is important, because it directs you to which metadata stream you may need to go to, or what additional behaviors you might expect to see. If I'm seeing CIFS here, what I might expect to see is, okay, file share enumeration. If we're to dig into recall or stream, what I want to be looking for is, maybe other files that are being written. So, do we see executables, for example, PSExec being brought over as one example there. Now with RPC, right, the goal, it's all understanding what the goal is, right? RPC is used to either gather data or to execute a task, right? So you need to understand what's trying to be done. Now the exact commands are not visible at the network level, so we can see that a task was scheduled. We can't tell you at the network level, what that actual task was. That is where things like endpoint logs, EDR come in handy, because we see that initial suspicious activity, and then you can use those tools to get more information. So highlighting RPC Targeted Recon, right? So this is designed for one host going to another host in sort of a one-to-one relationship, and looking for or pulling specific information in a sort of one-off event, and something that we have not seen before. So using as an example, right, in this particular, what I've highlighted, we don't have an account that's shown to us, but it's on 42.60, and it is querying get NC changes, which is a replicate updates. So this is part of the DRSU API, and it's from system 40.42. What does this look like in the actual system, right? We see that, hey, this is unusual for this host to make this request to this target. So what do we know? Well, we know the host is trying to replicate data. That's what that call is. We know that DRS get NC changes is typically used with domain controllers. As an investigator, this may raise hairs on my neck a little bit. What's going on? And we know, because we've highlighted it, that the activity is not expected from the source. So for all of this, context is key. What is the role of the host? What is the role of the destination? Is this a instance of maybe not having grouping correct in the system, or is this coming from a user machine, right? And again, using your additional security tools to find additional supporting evidence as to something that's going on. Moving from recon to actual execution, we have sufficient execution, right, which is looking for this subset of UEIDs that are meant to actually effectively execute code, right? So this is triggered off of a combination of source host, destination, account, and the main pipe, and finding abnormalities in there. So as an example, right, account Piper from Piper desktop is starting a service on a Deacon desktop. What we've identified is that this relationship to Deacon is strange, and the system has not seen this sort of activity before. So again, going to what do we know, Piper is starting a service. The account is operating from Piper desktop. And we know that if a service was started, something happened, right? So where do we go for that? Starting at the bottom, again, security tools, if you're looking for maybe specific code or the requests that are being made. But within the system, like, all right, well, what else do we see? What do we see on Piper desktop, or what do we see on Deacon, particularly Deacon, because if you're starting a service, if you're starting or scheduling a task and kicking it off, like, we kind of expect follow-up. And that's exactly what we see. So the top left, apologies if it's a little difficult to see, is coming from Piper. But what you have is that sufficient execution, and then shortly thereafter, an internal stage loader, which is basically a call out followed by a call response showing up on Piper. Shortly after this, if you look at the timestamps, you have a hidden HTTPS tunnel detection triggering off on Deacon, right? There's this correlation. Now we haven't necessarily proved causation yet, but there is a correlation between this. So it's understanding this full narrative and understanding what that actual use case is. So having said all that, I will open up for questions and answers. I know we brought down to about 7 minutes left. There's a lot to cover when it comes to Kerberos and RPC. This is really just kind of scratching the surface, but hopefully it's provide you some insight into how to actually approach these detections and this traffic in general. But happy to talk more either through here or afterwards. So I think with that, Sri, I'll turn it over to you.
Awesome. Yeah. Thanks, Jonathan. I know that was a lot of information. I'm sure everyone found it helpful, though, to kind of walk through slowly, context, everything like that. We did have a question come through, and it's actually related to your common attack slide, which going through the deck looks like it's slide 22. So this question is, do we need any third-party integration in order to detect Kerberos as shown in this slide?
Yeah, so third-party integration is not necessary. So what we're doing is it's not a direct detection of the Kerberos, but the use of the ticket once it's been compromised and decrypted, right? So as long as we have that Kerberos visibility, we will have coverage over such an event. If for whatever reason there's a reason we don't have that visibility, or we can't get it, we do have the ability to take in Windows event logs, which can help augment that.
Cool, thank you. So this next question is saying, we know that hidden HTTPS, HTTP, DNS tunnels means using a protocol over those same three. Can we identify this protocol while investigating incognito? So
if I understand the question correctly, and correct me if I'm wrong, so those tunnels, it's what we're detecting is abuse of those protocols. So that secondary protocol that we're talking about is more of a sort of conceptual one, where there's this communication that's happening that is, I would say, against what the typical protocol would do. So if you think of a DNS query, right, the protocol is to make a query, you get a response back. That secondary protocol that we're talking about is the fact that the queries themselves contain information, and whoever's receiving those can then use that to, either issue additional commands or to, exfil data, that sort of thing.
Excellent, thank you. We'll pause in case there's a couple more questions that come through. I think everyone's still processing.
Yeah. Hopefully I did not put everyone to sleep, but...
No, I'm sure you did not. And for everyone who's still listening, so the slides will be provided to you as well as a recording of the webinar. So you can go back, you can take a look at Jonathan's comments as well as those screenshots in a little bit closer detail in case you were having difficulty seeing some of those pieces that Jonathan was highlighting. And looks like we're good on questions. So we'll go ahead and close the webinar just a few minutes early. Thank you for everyone who joined us today. Thank you, Jonathan, for an excellent session, and we'll see everyone on our next customer webinar series, which will be shared shortly. All right, have a great one, everyone. Thanks for joining.